Hello everyone. In this video, we will discuss about the hydroformylation with a cobalt catalyst. So we know that hydroformylation simply refers to the addition of hydrogen group and a formyl group, carbonyl, across a double bond. So this we are going to do with a cobalt catalyst, HCOCO4. But directly it is not available. So we begin from CO to CO8, where if we add the hydrogen, it will be breaking down into HCOCO4. So whatever HCOCO4 that is being formed, this we call it as a pre-catalyst. Why do we call it as a pre-catalyst? Because HCOCO4, if we just go by neutral atom method, or you call it as a covalent method or ionic or oxidation state method, suppose if I am going with a covalent method. Through covalent method, I take hydrogen as 1 electron, cobalt as 9 electrons, and each carbonyl is a 2 electron donor, 4 carbonyls. So we have 18 electron system. Since HCOCO4 is an 18 electron system, it directly cannot participate in catalysis. It has to lose a ligand. Once it loses a ligand, then it will be converted into a 16 electron system. Where it can add on to the substrate. So it is losing a carbonyl. This, let us take it as a first step. So here if I just add the electrons, now this is giving a 16 electron system. For this 16 electron system, now let us add a alkene. So in the very first step, alkene is added, and this alkene addition is not directly occurring as a sigma addition. This is like a pi addition. So after this pi addition, in the next step, slowly there will be alkene insertion. All these are individual reactions which presently I am not discussing. There will be an alkene insertion. This we also call it as a sigma to pi rearrangement. So in this case, if at all we count, just a second, this is 1 plus 6 plus 9, and this is taken as 2 electrons. So 9 plus 1, 10 plus 8, it is a 18 electron system. This one is a 18 electron system. After alkene insertion, it is 9 plus 6, 15, plus this is taken as 1 electron in the neutral atom method, so this becomes a 16 electron system. Now after this, we have one more step where we will be adding carbonyl. Slowly carbonyl must be added. So once we add carbonyl, then altogether there were 3 carbonyls already. Now fourth one is also being added. Since this is a 16 electron system, one more carbonyl is added, so this becomes 18 electron system. Again, we need not count it. This is a 18 electron system. There is one more step which we call it as carbonyl insertion, which is the fifth step. So due to this carbonyl insertion, we have again CO3, but this carbonyl is undergoing insertion between the metal and the alkyl group. So we have C double bond O, CH2, CH2 and R. In the next step, slowly let us add hydrogen. Once hydrogen is added, this hydrogen will break down into 2 hydrides. COCO3 is as such, and C double bond O, CH2, CH2R. Acyl group is also as such. If we go for the electron count, 9 plus 6, 15. 15 plus 1, this is a 16 electron system. But once hydrides are added, these are 2 electrons of each hydrogen plus 9 electrons plus 6 electrons plus 1. This is giving 18 electron system. This is the 6th step. And in the 7th step, we can just see that R CH2 CH2 CHO is coming out, whereas the catalyst is getting recycled. So if I count the electron system carefully, if at all we look at the electron system, from 18 we started, which is a pre-catalyst that cannot act as a direct catalyst, so one carbonyl has to be lost. Once carbonyl is lost, it is giving the active catalyst HCOCO3, which is a 16 electron system. It is adding on to the alkene, and once it is adding on to the alkene, it is a pi addition. It is giving an 18 electron system. After 18 electron system, we have an alkene insertion, which is giving a 16 electron system. After 16 electron system, there is a carbonyl addition, that is again giving an 18 electron system. Whatever carbonyl that has been added, it is undergoing carbonyl insertion. So after carbonyl insertion, we have again a 16 electron system. And after this carbonyl insertion, there is a hydrogen addition. Once this hydrogen is adding, that hydrogen will add as hydrides. It is not dihydrogen, but it is hydrides. So slowly one of the hydrogen and the acyl group is coming out as an aldehyde, and the pre-catalyst is being regenerated. So this is the catalytical cycle for hydroformylation with cobalt as a catalyst. And this is one of the best examples where we can show different types of reactions that commonly occur in the organometallic chemistry. The first reaction, if I write, it is a CO dissociation step. Carbonyl is undergoing a dissociation. Second step is alkene addition and a pi complex formation. Third step is pi to sigma rearrangement, or we also call it as alkene insertion. Now, after alkene insertion, fourth step we have CO addition. Fifth step is CO insertion, or we also call it as alkyl migration. This is a separate topic to be discussed. Hydrogen addition, but this is not a simple addition, this is a oxidative addition, a very important step in the organometallic chemistry. And once oxidative addition of hydrogen occurs, the very next step is followed by reductive elimination. It is not again a simple elimination, it is a reductive elimination of aldehyde. Reductive elimination of aldehyde will regenerate the catalyst, and the catalytical cycle will continue. So this is about hydroformylation using a cobalt catalyst.